Thermodynamics. What is Gibbs free energy in mixing? Imagine pouring two different liquids into a glass and watching them blend seamlessly. Have you ever wondered what makes some mixtures happen naturally while others resist? That's where Gibbs free energy in mixing comes into play. It's a way to measure the energy change when substances combine, helping us understand why some mixing processes occur spontaneously. Gibbs free energy, often just called G, tells us the maximum useful work we can get from a system at constant temperature and pressure. When we mix substances, their total Gibbs free energy changes because of two main factors: entropy and enthalpy. Entropy is about disorder or randomness, and enthalpy relates to heat content. In many cases, especially with gases or ideal solutions, the main driver for mixing is the increase in entropy. When different substances mix, their molecules can arrange themselves in many more ways. This increase in disorder makes the system more stable. Think of it like a crowded room where people naturally spread out rather than stay in groups. This spreading out lowers the Gibbs free energy, making the process spontaneous. Mathematically, for an ideal mixture, the change in Gibbs free energy during mixing is written as the sum of the mole fractions times the natural logarithm of those mole fractions, multiplied by the total number of moles, the gas constant, and the temperature. Since mole fractions are always between 0 and 1, their logarithms are negative. This means the overall change in Gibbs free energy during mixing is negative. A negative Gibbs free energy change indicates the process will happen on its own without needing extra energy. So, gases or liquids tend to mix spontaneously because the increase in entropy outweighs any small heat changes, which are often negligible in ideal cases. After mixing, the total Gibbs free energy of the system is lower than before, meaning the mixture is more stable. Understanding this helps explain why substances like alcohol and water mix smoothly or why gases like oxygen and nitrogen blend effortlessly in the air. It also plays a big role in chemical engineering, materials science, and even biological systems where mixing is essential. In essence, Gibbs free energy in mixing measures the balance between energy and disorder. When the entropy increases during mixing, it lowers the free energy, making the process naturally favorable. This concept helps us see why mixing happens easily and why some substances prefer to stay separate.